Do you think the way that you've been talking about looking back at evolution could inform the way we're making AI models today? And some of the flaws and problems that these large language models have is that we're not doing any sort of evolutionary process to them. It is just bulk scaling in one moment of information.
Well, I think the biggest issue there is that they're treating the problem as an input-output mapping, right?
Right.
Large language models and almost all neural networks are essentially doing input-output mappings. And so in a sense, the idea of feedback control already says that's wrong, right? That's not what behavior is like. And so if you can describe behavior as a input to output mapping, but then you're missing half of it, right? You're missing the other half, the output to input, which gives meaning to the whole thing. So anyway, because AI systems and computer models have mostly focused on the input to output part of behavior, for that reason, I think they lack what's called grounding. This idea. I guess I'll explain.
Yeah,
Anyway.
please cover it.
So there's this idea that how does a system know the meaning of the representations that it contains?
Mm-hmm.
Something like a computer, like a large language model that's having a conversation. Does it actually know what it's talking about? And the answer is no. It doesn't actually know. It knows it knows the syntax. It knows how to form sentences and paragraphs, but it doesn't have any access to the meaning of the concepts, because the meaning of the concepts has to do with things like interacting with the world. And so in other words, if you have a control system that is interacting with, let's say it's seeking food, and it has categories that are useful for deciding whether to approach or avoid something. Those categories have meaning in the system because they are actually they are actually affecting the animal's state in the world. They actually are accomplishing the goal of the system,
right,
which is to affect the state. And then so that's acting through the world, right? So that's an animal going out there and controlling its internal nutrient state by acting through the world and approaching things. But a creature can also control its nutrient state by acting through the world through other creatures in that world, right? So instead of going and reaching for the apple, I can say, "Hey, could you hand me that apple?" Right? And assuming that there is a benevolent, understanding being that I'm speaking to, I will get that apple, right? Simply not by walking out and grabbing it, but by uttering some sentences, some noise, making some noise out of my mouth that happens to persuade this other person to go and hand me the apple, right? Now, that works because other agents, other humans in my environment are incredibly sophisticated, but relatively predictable, right? In so far as, we establish some relationships with each other. And so because of that, I can control my nutrient state, right? And so now you can say that the utterance that I just made with words like please and give and apple, those things serve a function for me. And I know what that function is because I use them to control my nutrient state. And so and the animals do this too. Animals influence each other and get things through each other, control their state through the others.
right.
But we take this to a really high level, or a really abstract level, right? Like, for example, we build relationships such that next time I ask you for an apple, you'll give it to me as opposed to throw it at me or take it or whatever, right? And so we build these relationships so that we can then later interact in these useful ways, and I'll give you an apple when you ask for it, and you give, the point is that there's these little utterances, these little noises that I make work because there's a shared understanding of what you will do when you hear them, and I can make, on the basis of that prediction, I can have a meaningful interaction with my environment, right? And it relies on very much on what's in your head. Now, again, and so those all those symbols like please and give and apple have meaning to me and to you because there's this shared interaction that they're referring to. But if you do that to a large language model, it's just trained on listening to the interactions that you and I had in which those words appeared in that order and certain things happened. And it's seeing the patterns. It's seeing the input-output patterns, right? But it's not actually learning any causal structure,
Right.
Of interactions that actually have the meaning, right? It's simply mimicking the pattern of noises that are coming between us, right? But the pattern of noises, we could be speaking a different language. We could make up a language, and we'll still have those interactions, right? And so the noises, the syntax, even the syntax isn't really the important thing. And so large language models and many neural networks really are solving a kind of a pattern prediction and pattern completion problem without actually ever being given the meaning, the problem meaning. So
Right.
they've never been given a chance to actually learn meaning. They're just learning the structure of spoken language. And so when I read the text that ChatGPT produces, on the basis of training on meaningful conversations between people, I will be able to interpret the meaning of those words because I know the meaning of those words, right? And so it's like the training set, the humans that produce the training set knew the meaning, and the person who reads the produced text, the transformed text, knows the meaning, but the transformer doesn't know the meaning. Right? It just completes the patterns. So it's this Chinese, this classic Chinese room argument, right? And I think it's essentially that.
Yeah.
I think again. So when I say to AI, sorry, I did warn you that I ramble.
It's brilliant.
So the thing with AI is, I think they're asking certain problems, certain questions, like how to do input-output mappings, and those are interesting or whatever. But I don't think those are getting at the basis of intelligence, which has to really confront the issue of semantics and meaning.
Right.
And I think I think you should do more, autonomous robotics, reinforcement learning models, things that actually are constructed to learn interactions as opposed to input-output.
Right. I was talking to Dr. Tony Zador on the podcast.
Oh, yeah.
He was brilliant. We had a great conversation, but he brought up this idea that I'm sure you're familiar with about having AI agents in digital environments, and they could go through these environments and they interact with challenges, and then they would evolve in, a way that you could possibly analogize with how organisms interacted with their environment and evolved to overcome those challenges. My question was I'm sure you're familiar with those sort of paradigms and how a model could be created from that. And I think that's a really cool and powerful idea. But I'm curious about how would you design those environments? How would you choose what challenges to put the agent through? How would you know what to throw at them so that agent might, evolve in the way that you might want? Or is there any way that you'd be able to predict how that agent would evolve in different scenarios?
Well, I think, that's a cool question. I mean, I think it depends on what you're trying to get out of it. If you're trying to make an artificial system that's just good at something, then I think there's many different ways to make that environment. And I'm not exactly sure what I would suggest. I mean, obviously you want to start it with something relatively simple,
right,
and then gradually make it more complex rather than just give it an incredibly complex problem there's no chance in solving. So, I mean, there's a lot of these kinds of studies that have been done. I don't know if there was classic work from Carl Sims where he essentially reinforced these sort of virtual agents to travel, either jump high or travel across a horizontal surface quickly using sort of realistic physics. And they would evolve all kinds of crazy strategies for
That's
moving
so
their
cool.
bodies. Some looked biological and some were just completely crazy. So, I mean, I think if you want to accomplish a goal, then I think it's fairly open-ended as to how to do it. But also then it's kind of hard to know how to do it, right? Because you don't know where to start. I would say definitely though start with something simple and add to it. Right, Rodney Brooks suggested, this kind of idea of building behaviors on behaviors. So first get it moving and then get it steering and then have it, sort of control that steering in some sensible way. If you wanted to build a model of a actual biological brain, then you have more, I think, guidance as to what stages to take it through, and then do something like, all right, let's think about a mobile predator that has to orient itself and catch things, and then it'll be like Bratenberg's vehicles or some kind of a sort of steering system and you could base it on biology. You could base it on studies of fish and lamprey and zebrafish, for example, a very well studied. And then you could think about, all right, let's get this thing now. It has to get out on land, has to locomote on land. How is it going to do that? And so Ike Speart, and I'm probably mispronouncing his name, has been doing this kind of thing where he sort of has these sort of robot salamanders. I mean, actual physical robots, but also simulated.
Wow, that's so cool.
What salamanders can swim and walk and do it in a sort of biologically plausible way. And his engineering type solutions are actually pretty good models of the spinal cord.
Wow.
And so you could do that, and then you could keep going with that. You could go for something that, let's say, then guides itself with optic flow, like fish do, surely, but also certainly out on land, animals do, and have sort of autonomous robots that take advantage of certain properties of the world, like optic flow, for example, which can be a very robust strategy for controlling yourself while running through the world. So, that might be, so on one hand, it'd be really good to do it. It'd be good for understanding the brain to build artificial systems in this way that actually mimics what happened in our lineage. But it might actually even be a good way to get just if your ultimate goal is having artificial intelligence and not necessarily a model of the brain, it might still be a good way because it did work, right? In us. It did create these creatures that are capable of
Took a while.
things. Yeah, it took a while, and it probably would take a while going that way. And I'm sure some of the steps are completely unnecessary.
Right.
Like becoming nocturnal and becoming diurnal again. Yeah, okay, that's shifted sort of the brain structures, and it had a fortuitous consequence, is that because we relied on the neocortex instead of the midbrain, it so turns out the neocortex is, well, according to some theories, is easier to enlarge than the midbrain because of its structure. And therefore, by relying on it, opened us up for later becoming really sophisticated because we've got this thing that we can really enlarge. And it's really for very mundane reasons why it enlarges more easily than other things. It has to do with wiring efficiency and things like that. Anyway, the point is, so maybe there's some things that were useful, but I doubt it. I doubt you'll actually have to go through all those convoluted things if your goal is to make an intelligence.
Right.
But I still think one thing you absolutely need is you need to have semantics. You have to have that kind of closed loop interaction, and be working on expanding it, essentially taking a simple feedback system and let it learn how to expand its control into more abstract domains. Like there's the point of I see an apple, I grab it. Then there's the idea of I see an apple and I ask someone to give it to me. And then there's the really abstract thing where, I put money in the bank so that later I can go and take it out and buy that apple. There's levels of abstractions that we have reached, but they're all, again, the context is always some kind of a behavioral state control.
Do you think so the goal that they talk about, the goal that Sam Altman talks about and people in the industry say is AGI, so a generalizable artificial intelligence. Do you think that to build something like that, motion is intrinsic, like having some physical body that you are actually moving and navigating within a world, is that fundamental to AGI, which is, I don't know, we can arbitrarily define that now because it's defined by lots of different ways. But do you think motion is intrinsic to that for some reason? By the fact that the computer is obviously just servers somewhere in a building. Does it need to be attached to a robot that's moving to get to the next level of intelligence thing?
Yeah, so I mean, I think there's many ways you could define intelligence, but
Right.
if you just think about like human-like AGI, then I don't think it has to be physical. I don't think you have it in a physical body that's actually interacting with the real world. But I do think interaction is necessary. So whatever virtual world it's interacting um, has to. I mean, again, if you want it to be human-like, it has to sort of have some of the same contingencies in it.
Right.
Like for example, two objects cannot occupy the same place at the same time. That's a really reliable fact of life, and that's something that brains can use to simplify the problem of guidance and such. Certain aspects of geometry, something in front of you that's out of range will be in range if you move forward. Very simple, kind of like obvious facts of life in a physical world. I think if those are there, then you build artificial systems that deal with that, then again, semantics is necessary, right? You have to have that closed loop, and you have to give the system some way of expanding that loop, whether by your evolving it, sort of, through kind of like an intelligent design type thing, or letting it stumble onto solutions. But anyway, the point is, you have to give it the ability to expand its domain of interaction towards new levels of abstractions. That's what
Right.
happened in humans. I mean,
Right.
the remarkable thing about human brains is that they adapted to a kind of a complex, large primate living in social groups, hundreds of thousands of years ago. And yet now we're using that same brain for very different types of activity. Our lives are really different. I mean, one could say that the most important parts of our life are still the same. It's still sort of the social group and the interactions that we have with specific individuals. But we're also capable of doing all kinds of really bizarrely abstract things that
Right.
those humans never did. And so if we could build a artificial primate that solves the kinds of problems that primates deal with, including the social interaction problems, I think we'd be a long way to real human-like AGI. Rather than go right into language and complex knowledge or something, I would say that we go a little bit from the past to the present, and build a structure, build an architecture that's capable of dealing with the kinds of with the niche that primates live in, and then I think we're almost there. I mean, maybe that's silly, maybe that's just underestimating the massiveness of the problem, but I do think we'll be a lot of the way there.
Right.
And it's human-like intelligence, right? So there's certain things that, for example, the serial order of our thinking and our behavior, a lot of that has to do with the fact that we're dealing with a geometric world. You can't do multiple things at the same time. Again, two objects can't occupy the same place. And some of it is kind of arbitrary. Like the fact that we have forward-facing eyes and we rely so much on vision creates a kind of a serial order to a lot of our strategy of dealing with the world, because we look at one thing or we look at another thing, and then we act on the thing we look at, and our gaze controls us, determines so much of what we do. And a lot of our strategies, I think, for dealing with the world use that kind of system. We look at things, we appraise, we decide, no, that's not what I want to go for. I'm going to look for something else. That actually shapes sort of the structure, the sort of sequential temporal structure of our intelligence.
Right.
Whereas a artificial system just said, go be intelligent, doesn't have any of those constraints. It could do anything. But again, if we want it human-like, it kind of has to have similar semantics. And I think those semantics are going to be very much embedded in a geometric world of some sort. Again, I don't think it has to be physical, because there's, once you start building a robot, then you're you're spending all your time like fixing little broken wires and greasing gears, or I don't know what. I mean, you're not doing the theoretical stuff. Whereas if you're doing it inside a simulation, you can sort of do away with the wear and tear and all the other things. But I think it has to be a pretty good simulation, right?
Right.
You have to do something like like an Unreal Engine with good physics, and really let it have to deal with the actual the output input contingency. That if it moves, what's the optic flow that results, or
Right.
what are the forces that result? Things like that.
Well, I saw only 2 days ago or something that Google DeepMind just came out with their infinite world generator. I don't know if you saw this. It's just a model that's capable of creating infinite virtual worlds. And you can.
Well, I mean, yeah. So, I mean, you can, but I wouldn't say jump right away and throw it into a really complex world, right?
Yeah.
I mean, you can give it world. You can sort of, babies don't make it out on their own right away, right?
Yeah.
Give them a little bit. And in fact, actually, I think that this kind of curriculum learning idea that you sort of train them in a way that makes later learning easier. I mean, that's what we do. You don't just say to the baby, you don't just give a baby the entire internet. Here, learn how to talk.
Yeah.
Like ChatGPT. No, you first teach interactions. You make them notice that when they make a noise, the parent comes and gives them that apple. So the point is, I think we need to gradually train it towards more complexity, and I think we want to maybe start with a relatively realistic world, but maybe one in which there's a parent, essentially a benevolent, complex creature that's easy to control, so that you don't actually you actually learn how to control your parents before you learn how to control your arms and legs, right? Right, because they're so easy to control.
Right.
The parents, I mean, do you have kids?
I don't, not yet, no.
Okay, well, if you do someday, look out, because you'll see how easily controllable you are.
I'm sure I'll be manipulated to do all sorts of things against my will.
It's wonderful.
Yeah, I'm sure it will be.
It is manipulation. Anyway, so the point is, I think to make it easier on the AI, we might want to sort of take a lesson from that. You learn how to control your world in a sort of safe environment without major damage, and then you gradually make your way out, or you start crawling and walking and jumping, and speaking is the same thing. You first learn just how to get somebody's attention, then you learn how to steer them slightly into giving you food versus water, let's say, and so on. And you build those interactions with them, and they actually help you. They actually have to make it simple. So it's almost like Robo Baby. Baby AI is a project that Yoshua Benjo is doing here. I don't know what stage it's on, but basic idea that you want to kind of train them,
right?
Kind of like a baby. Right.
It's so fascinating. It's so interesting. And who knows where it will be a couple of decades from now, a radically different place than it is today. Are you overall?
Yeah, well, I am a little bit
pessimistic?
I am a little bit, sorry?
Nihilistic, pessimistic?
Not pessimistic, but a little bit sort of disappointed maybe about how people have focused on the input-output mapping issue to almost the exclusion of everything else, because I understand the value
it's
of
made
having
a good commercial product, right? I guess they were really.
Well, I mean, the value of having a machine vision system that's as good as some of the systems that exist, or a translation system that's as good as or ChatGPT, which with its even with its flaws, it's pretty impressive, right?
Yeah,
the value of these things is so high that it's taken over the field. But I think there were other things that were being done,
right,
that I think were better long-term for long-term progress, like realistic reinforcement learning as opposed to gigantic data set reinforcement learning. Those kinds of ideas, I think, were leading to good directions. I think they're being abandoned because everybody's just jumping on the bandwagon of where
the gold rush. Yeah.
But in the end, I don't think it can work. In the end, that thing is going to produce all kinds of very useful things, but it's not going to produce AGI because it's missing the semantics.
Right.
And so I'm frustrated by that because maybe it'll be 25, 30 years before people come back to those, what I think more promising viewpoints, but I'm going to be like 80 at that point,
It's
I,
difficult, right? Because these companies have to fund their research somehow, and when OpenAI are just making free, they just released a $200 per month subscription. When these companies are printing money, the VCs, venture capitalists, how these startups work is just that's where the money is going to fund, large
well, but my
scaling.
understanding is Wall Street is starting to get a little bit fed up with AI.
Yeah,
The hype,
maybe, you
yeah,
know.
that because the hype has been so high
Yeah.
that it can't possibly live up to it, right?
And development,
It's
I think, in the last sort of 12 months has probably stagnated a lot more than people thought. Once ChatGPT was released and then Claude and Mistral and those models were coming out, I think people kind of expected that linear or exponential increase to just keep going, but it plateaued earlier than people think or people thought it would. What is your overall, even stepping outside of neuroscience for one final question, are you overall pessimistic, optimistic, nihilistic? Like, what do you think the end result of AI a couple of decades down the line will be in the overall economy?
Well, yeah, I don't know. I don't know. Of
Yeah.
course, I don't think the current approach is going to produce AGI. So, and that's in some ways good,
So you're
right?
not as
So we're not going
scared.
to have the Terminator scenario.
Yeah. Yeah.
I don't think we're really in danger of that because it's not trying to achieve its own purposes.
Yeah.
So maybe it's good,
Yeah. Yeah.
actually, for society.
Yeah.
I don't think there's going to be another AI winter. I mean, AI has, as Jan LeCun said, died like many times already because of all the hype. Right now, I think there probably will be a big bubble bursting, but I don't think it's going to burst to nothing. I think there's
Right.
still, I mean, the things are useful. The things are undeniably useful, and they will remain useful, and more useful things are going to come up with. There's going to be plenty of innovation. I think I wouldn't necessarily, I don't know, I wouldn't necessarily, as a young person, devote myself into that field because, as a high school student, because by the time you graduate, the hype may have died off and it might be actually hard to find a job. It's a little bit like being a computer scientist. There was a time it was just incredibly, incredibly, it paid off, right?
Right.
Whereas, later, no, then like everybody else, you're struggling for a job. But so anyway, so I don't think it's going to really burst like AI winters in the past. But I do think there's going to be a kind of a unfulfilled promises. There's going to be a lot of people saying, "Where's my robot butler?"
Right.
Even self-driving cars. I don't know. I don't know if
Really?
we're going to be, because robustness is so important there.
Right.
And I think different approaches might be needed, but I think probably there will be. I think just with the machine vision and all that we know about control systems, I think probably maybe. I'm not getting into one anytime soon, but not the robot butler. That's
Damn it.
don't hold your breath for that one.
Damn it.
Or many other AGI type dreams that people have. So I think there's going to be a bit of a shift. And again, I think, and many people think that you need to have a more control theory oriented approach, more about sort of embodiment and sort of situated robotics. And people have been saying this for decades. Brooks most famously, but other people have said this.
Yeah.
And I think there probably will come into that kind of to try to capture the semantics. And but then I don't know. I mean, maybe it won't be so good, right? Because maybe then they'll be uncooperative or
Right. Would you?
I mean, I don't think so. I actually think we can. I think we can.
We keep the reins on and keep the leashes shackled.
Yes, and this is something that that we think about a lot around here. Is what do we really need? I mean, do we need them to, for example, serve their own goals, or could they actually be controlling the state such that the human is the one who benefits? I mean, there's no necessity for an intelligent control system necessarily, I think, to be selfish.
Right.
It just has to have an understanding of the semantics of interaction. within which it works. The one problem, of course, is if we want it to be able to understand, if we want it to be human-like, where we can sort of have a conversation with it, then I don't know what we need to include or don't need to include.
Right.
Time will tell, right?
If all the money that was going into GPU clusters and scaling current sort of models like the GPT-o1, whatever the new models are, if you took all of that money and you put it into however you would train these models in complex virtual environments, literally all of that money, and there was no promise of, you didn't need to make a commercial product, all you were trying to do was make human-like models. Would you be scared of the potentiality of those AI models? I mean, obviously you're guessing because you don't know the results of those tests, but assume you could redirect all of that funding away from scaling commercial products into just research of like, how do we create AGI human-like models? Is that a future we should be nihilistic about?
Well, I mean, I think whether or not we do that, one of the biggest threats is always the bad actor.
Right.
Scenario, right? I mean, there's any technology can be abused, and more powerful technologies can be abused terribly. So that's always a danger, regardless of what it is. I think the danger of it getting out of control is higher in the case where you actually have a control system, right? Where it's just an input-output mapping, then it on its own is not really going to get out of control.
Yeah,
I think. It could be used in horrible ways by oppressive governments or whatever, or companies. But I think once you train it to be a control system, then it's a question of what defines the desirable state. If it's a just and fair society, a functioning society, well, that would be good, but it's not going to be easy to set up that kind of set of criteria. I mean, I think I think it's going to have to be done very careful. And I think that even though I feel that there's a lot of sort of scare things being said about, oh my God, the AI is so powerful. A lot of that I think is just clever marketing. It's like, my God, my system is so powerful. The government better put some reins on it, and then of course right away the investors come.
Yes. Yes.
So I think a lot of that is just marketing. But on the other hand, the fact that attention is being paid to these issues, I think it's never too early to start, right?
Yeah. Okay.
It's never too early to start thinking about it just in case. And I think it's good that people are thinking about human-aligned AI, even if I don't think the danger is imminent.
Right.
At some point it might be imminent, right?
Absolutely.
And so I think it's all well spent effort. As far as all the money that's put into scaling, no, I think if it was put into different kinds of systems, I think it would have a different outcome.
Right.
But I have no idea what that would be, right? I mean,
yeah,
I have some ideas about what's missing, but that doesn't mean that it's going to be like a silver bullet, right? It's not. Right. It's not necessarily. There's not 100 other things missing. So,
right.
Paul, but I don't think the if it doesn't work, make it bigger is really good strategy. I don't think that ultimately is going to make it.
That seems to be the dominant opinion of most of the neuroscientists that I've talked to on the podcast, is that they just don't think scaling gets you there, because they know, or they understand that human element a lot more than computer scientists.
Dr. Paul Cisek, what an absolute goldmine of information. If you enjoyed that short clip, then I'm so confident you're going to enjoy our full 2-hour-long conversation, which basically covers the entire evolution of the human brain. You just have to click it here. You can click it right now, here.